that are key into the authentication piece. As anybody who's worked with OAuth, and specifically OAuth within Spinnaker, this will ring true. What we're going to do here is we're going to walk through a series. I'm going to turn this off briefly. Can you guys still hear me from this mic?
Yeah.
Okay. So what I'm going to do here is I'm going to go through a walkthrough. I would also recommend if you guys are doing any kind of development or actually trying to get your Spinnaker deployment running, do everything in an incognito window. It will save you lots and lots of hassle, especially when dealing with sessions. So what we're going to do here is turn on a specific feature in Chrome that is to preserve the log. This preserves the network traffic as as we're going through this login workflow. So we're going to go to stage, and because I have a self-signed certificate guarding this, we are going through the authentication process. Logging in here. I've been noticing all morning my Kubernetes cluster has been kind of slow, so this takes a little bit longer than it normally would. All right, and so you notice the page reloads, and then you see up here in the top corner, our identity is in there, and we have authenticated to the system. What I want to show you is when we. All right, so let's go through like what just happened there. All right, this is a little bit better. Okay, so I told you a little bit before that DEC is a set of static HTML and JavaScript and CSS and all that living on an Apache server. So what you'll see here is the first few requests are those requests going to that Apache server that is specifically loading the app. I told you app.json is the one that has 1.2 megabytes of JavaScript that's coming in. But what we're going to look at first is this settings.js. And I'm not going to look at that one specifically yet because I actually want to show you the contents of it. If we look here at this settings.js, this, like I said, this is a static file. It's the same thing wherever you go. And what we're looking at specifically is this auth enabled flag. This auth enabled is telling the application that you need to go through the authentication workflow that DEC knows about, and that is everything that we're going to dig into here. So what is happening behind the scenes is you'll see in the traffic here, one of the first calls to gate is to this auth/user endpoint. If you're not familiar, 8084 is gate's a standard port. So this call goes out, comes back, and it has nothing in it. You can see here, content length 0. This is how DEC knows that it needs to go through the authentication flow. Okay. What it does is it makes a request to this /auth/redirect with an argument that is to the current page. Now what this endpoint is, this auth redirect endpoint, is a protected endpoint that invokes the Spring Security login mechanism. Okay. And you can look here and you see the status code 302 redirects you to this location, which is back to the this redirects you to a point on gate that says login, and then we can follow that within the network tool here that says, okay, make that request to /login, and that itself returns you a 302, which returns you to, in this case, we have Google OAuth established, and this sent me to the accounts.google.com page, which was the login. You all saw me, login, username, and password. And so, as this goes through, some of these requests are all the interaction of the browser going to Google back and forth, establishing my username and password. And then what ends up happening is, actually, one of the things, where are we? When I, let's see, when I make this, this request to accounts.google, where am I? Very next call. So let's look at the query string parameters that we have here. So this request to Google included the OAuth client ID, which is just some long auto-generated string, a redirect URI that Google will send us to once the user has actually logged in. So you'll notice that it just sends us right back to the login page. And in this case, we're also asking for the scoped profile and email. If you're familiar with OAuth, the whole point of OAuth is kind of an authorization mechanism. We're kind of piggybacking on that authorization mechanism to validate your identity, and that's really what the authentication piece is trying to prove that you are who you say you are. So we are getting Google, in this case, to allow us access to your profile to confirm that you have ownership of that email address. That's the only reason why we're asking for the email and profile scopes. And you also notice that this has a state variable, which is 6-digit. This thing is to help prevent some cross-site request forgery. Or a replay, I'm not sure which one. But anyway, so you'll notice here that so once we've all gone through the login, and then we have to go back and search through all the stuff again. So remember that redirect URI said, once the user is logged in, I want you to forward the user back to my /login page. And in this case, this is what that request looks like. Here's the /login. It includes that same state variable, which is that cross-site request forgery code. And then also this, this code. In this case, this is an authorization code. So what is happening behind the scenes is that in the processing of this request, Gate is using this code along with its client ID and client secret, and it's going to Google saying, give me an access token so that I can make a second request to validate that this user is who they say they are. So that is that third leg that we showed in the slides about how Gate and the identity provider, these guys specifically for OAuth are talking to each other outside of the user's workflow. Okay, so what that means is, all right, we've logged in the user. This is great, but the hard part is because Spinnaker is a single page application, we have to get the user's browser back to a state in DEC so that they can resume whatever it is that they were doing. And this is kind of why we have this /auth redirect page and why it's considered a protected resource. When you hit this endpoint, at first, when you're unauthenticated, it saves that URL into your session. Once you are logged in, it pulls that URL back out of your session and sends you there. Okay, but what is the purpose of this endpoint? It is literally to redirect you back to the starting point of Gate so that we can give control back to your browser and the JavaScript within it. All of this is happening behind the scenes without you having to continue to interact with it, which is why you saw the page refresh and you saw the Spinnaker logo and the I am the walrus or whatever funny sayings that they have down at the bottom. And that's when you see the whole page reload. And you'll see here init.js, which is the same thing we saw at the very top, and it going and reloading all of the same things. Settings.js, app.js. And then specifically, because remember when we started off with this, we went to the /auth/user endpoint. In this case, we actually have a response coming back. In this case, we now know, or Gate now knows that this is a valid session and that this user TOMSU Spinnaker test is for real and you can let them through. So that's kind of how DEC and Gate have this this dance back and forth, passing control between deck, gate, and the identity provider to actually go through your whole login flow. And so this means so much more now that we've walked through that, because it is a complex process. And if you want to see everything that I just went through back in sequence diagrams, you can go to our spinnaker.io documentation page and kind of walk through that. And use the incognito window, and you can and watch the traffic go back and forth, and it kind of makes a little bit more sense. All right, so let's talk a little bit about the implementation here. If you've been to any of the other developer sessions and everything, you might have heard that we use Spring basically everywhere. So it's probably no shock to you that the security is implemented with the Spring Security library and framework. This buys us a lot of good things, in that we can, with configuration, plug in specific implementations of however your enterprise deals with users. We just walked through the OAuth flow. It's the most complex one, but it also, once you have it set up, it's probably the most secure. That's not anything to say that SAML and LDAP are insecure, but SAML and LDAP generally require you to work with your account administrators in order to get everything set up. Whereas OAuth 2, you might, depending on how your enterprise is structured, you might be able to set this up without their involvement. Lastly, X509 is also an authentication option. If you were here watching Cameron's extending Spinnaker talk this last session in here, you might have seen some of the stuff that Netflix does with X509 and how they enable script access and programmatic access to gate using X509 client certificates. All right. So who here has actually worked with Spring Security before? Raise your hand. All right, so a small bit of you. The authentication interface in Spring Security is like kind of the core piece. All of the different authentication and authorization mechanisms that we use have a specific implementation of this interface. And it's pretty simple here, as you see. These are all kind of details that if you were developing a new interface here, a new thing to plug in, that you'd be intimately familiar with. The second key piece is this notion of the security context holder. This is how your user and their browser is making dozens upon dozens of requests to gate, and each one of them are being locked into your user, and your user is only able to see what is coming back, basically, so that no two sessions are crossing the streams. And it uses some thread local magic to make sure that, like within a single instance of gate, that no two authentication objects are being crossed. And it kind of does this with a complex set of security filters. And so that's what we're going to look at here. So within the application, the request and the response are both generated at the very beginning, and it goes through a series of filters both on the request into the application, like the application itself, and then each of the filters has the option to do something different with the response on the way back out. Does that make sense? Like this is a filter chain. It's a common pattern with web request frameworks. So the filters can each do something on the way in, and they can each do something on the way out. The big image on the right there, this is actually all of the session filters that all of the filters that a basic request is going through. Every request is going through whenever deck is making a request into gate. The two that I have highlighted here, the external auth token filter and the Fiat session filter, these are filters that we've written and have added in specific spots in order to extend functionality. For example, the external auth token filter. If you have if you're using GitHub to authenticate and you go out and generate a personal access token, you can build a scripting client, giving it that external token and a specific header, and everything will work. Everything will work as expected because of this token filter. It basically fishes out the value in that header, goes through all of the same OAuth flow that we kind of just walked through, but without the browser being involved. I guess one other thing to talk about here is the security context persistence filter. It's at index 1 up there. That is the first filter. That's like filter A here. It's the first piece of code that actually gets run whenever a request comes in. And then it's the last thing that can touch the response, or I guess the second to last thing that can touch the response before it heads on the way out. And that is what leads us to this. So as your Spinnaker deployment is getting bigger and bigger and bigger, depending on how big your enterprises are, you might actually need a large Spinnaker footprint right out of the gate. Not this gate, but you might end up needing to start to scale out gate right from the beginning. And each one of the services, each one of the microservices can scale independently and horizontally. And you'll see this is a very common pattern where you have some client is talking to a load balancer fronting one of the services that scales out, and then each one of those services is maintaining state in a separate Redis instance, so that each one of these can be versioned and it can be rolled out to newer versions, and then like I said, it can scale out and accept more requests. In this case, what we're doing is we're serializing the session. I guess the library. The library is serializing the session for us, storing it in in Redis, and then when the next request comes through, it goes back to Redis, grabs that, and uses that session. All of that's done with session cookies, and it coordinates all of that for you. And then, as we said, that session persistence filter is the second to last thing that can touch the response. Or in this case, it's actually going to save the session back to Redis so that the next request that comes in can have the most up-to-date version. All right, so Spinnaker is a set of microservices, and Gate is the only one that's actually making you go through this authentication dance back and forth. So how is it that the authentication propagates from the very beginning of it all the way through to the back end down to CloudDriver, where CloudDriver does all of the mutating operations? In this case, using some of the Cork and retrofit helpers that are built in, each one of the services have these shared libraries built into them, and they do it specifically using an HTTP header called xSpinnakerUser. This is part of the reason, if you look at our documentation, that we highly recommend that you either use the mutual TLS that Cameron once again mentioned in the last session, using mutual TLS between all the different Spinnaker microservices, or putting Spinnaker on its own subnet so that no other part of your application can talk to each other. Because all it takes is a header that is just identifying the user to grant whatever access that user has. All right. If you've ever been on the wrong side of a Fiat error, this is probably how you feel. So let's talk about Fiat. Fiat is the authorization server. This is the piece that determines whether or not you have approved or denied access to these resources. Specifically, what we're talking about is applications and accounts. We're going to go through the security model here. Spinnaker's security model is unrestricted by default. So that means whenever you're standing everything up and you actually do have authorization enabled, if you have not specifically locked down an application or an account, it's wide open. Anybody within your enterprise that has access to login can go in and modify that application or that account. But once you start adding restrictions there, only the people who have been granted authorizations can actually get in. You specify restrictions using this permissions YAML. This one would be an example of in CloudDriver restricting some account with groups that are either like all SRE, the team eng, and then the team SRE might have access to production environments, let's say. One thing to note is that all of these roles, the user must be one of them. All of the roles are kind of ORed together, logically ORed together. So Fiat has the ability to periodically reach out to an external role provider in order to resolve that, hey, we've got 100 users in our enterprise, and those roles get updated over time. Sometimes we need those updates to be reflected immediately. Sometimes we can tell the user to wait an hour or so. But by default, Fiat is re-resolving the users every 10 minutes. And the external service that we reach out to can be Google Groups. If you have a Google Apps for Work or a G Suite account, we can reach out to GitHub Teams, LDAP, and then also there's a new feature that if anybody's interested, I'd love to get some alpha users on this, that is just a straight file-based implementation. Spit out all your users in like maybe an ETL process once every 24 hours, and then we can, we'll just pull in that file and apply those permissions. Similarly, there's also another one using SAML, because the SAML assertion that comes over not only validates that you are who you say you are, but some SAML implementations will also send your groups over. And this is a great thing. This is actually how Netflix does it currently. But anybody in a large organization will tell you this is a double-edged sword, because sometimes your users are members of so many groups that it will actually blow up the SAML response, as Edwin will tell you. It'll, you'll get, I think it's 65K or something, but how many groups was that approximately?
Like 320.
320 some groups. So if your users are roughly, 300 in groups are so large, or they're in 300 groups, SAML might not be your preferred choice. All right. I'm gonna let you look at that for a second while I also read it, because there's a lot of stuff going on in here. So this is how the permission resolution is happening in Fiat. This is the process that happens roughly every 10 minutes by default. But if you have a large number of users, you might need to extend this out to maybe an hour, or maybe once every 2 hours. So you have some user that has logged in before. Okay, they have roles from your external role provider. We'll use Crime Fighter here to highlight what you have, but they also might have additional roles that don't apply to anything here. And then you've got your application and your account config. Okay, your account configuration lives within CloudDriver. CloudDriver is the source of truth for accounts. Okay, whereas Front 50, as being the config service, is the owner of the application config. And within that application config, you have the ability to specify permissions on a per application basis, or just leave them open. Which I had mentioned that everything, if left unspecified, is unrestricted. So in this case, what we're doing is we're taking all of the users' roles and then all of the accounts and the applications, and we're merging them into what a resolved user permission looks like. And in this case, user Batman has the role Crime Fighter, so they have read permissions on the Gotham Bank account, and then they also have applications for the mortgage account, both the read and the write permission because of that, and also to the ATM application, because the ATM application is unrestricted. Does that make sense? So this is the thing that's happening every 10 minutes behind the scenes. I told you this was all a deep dive, so we're diving into the implementation details. So as we showed before, when you have 2 or 3 instances of Fiat running, they are backed by a shared state of Redis, and this is the kind of the layout that that Fiat puts into Redis, and it separates everything out by application, by what roles they have, by accounts and service accounts, which we're going to get to here in a sec. And then, digging into any one of them, we actually have the serialized permission that says for this application, for this application, this user has these permissions, reads and writes. And then what happens in here is this is just listing out what role is actually giving you that right. Part of why we do this every 10 minutes is so that we have a resolved application ready to go whenever a user's request comes in. This is intended to be a high read service and an infrequent write service, which is why we want everything resolved and to be very quickly accessible. All right, so let's talk about service accounts. If you've been running Spinnaker for, greater than a year or so, you might remember when we had a legacy authentication / authorization system where Gate was kind of responsible for doing these calls to the role providers. And so when you locked your system down, that meant that you could no longer use a trigger to trigger automated pipelines. So we had to come up with a way around this, and one of them was, and this is service accounts. So this is a static file that just says, I want to have a service account named Batmobile. It needs users to be a member of Crime Fighter in order to gain access to this service account, and these permissions are resolved just like any other user. Spinnaker admins create this right now. If you are interested in writing a UI for me, come see me after this. But what's different with service accounts, different than the application and the account configuration, where when you listed all of the roles that were required, a user just had to have one of them. In this case, a user has to have all of the roles specified in the member of in order to have access to this account. This is to prevent a privilege escalation exploit, and it greatly simplifies the ACLs around robot accounts. Because there was an initial alpha implementation of this where it was just all kinds of confusing, and I was responding to questions in Slack all the time about getting service accounts working. All right, so let's go through an example here. User Robin has the roles Crime Fighter and Superhero, and now we've got 2 service accounts here, one called Batmobile and one called Lamborghini. Robin has access to Batmobile because he has all of the roles Crime Fighter that the Batmobile has specified, whereas he doesn't have access to Lamborghini because he also requires the Wayne family role in order to access that one. So that's just a simplified way to think about how to access service accounts. If anybody has ever gotten into to configuring your pipeline triggers and you have a blank run as user field, this is the root of it. This is the root of why. If you're interested, there is an alternative to setting up all those service accounts, and this is actually what Netflix ran with, I think is still running with. The first stage in your pipeline, you can just make it a manual judgment stage, and then check the propagate authentication. It's not the most ideal solution because obviously your pipelines are triggering and not actually running until somebody comes in and clicks the manual yes button, but this is a way to enable access to or triggered pipelines on protected resources. So I think this is not something that is commonly known. At least I haven't seen anybody in the chat room ask about this. But this is a way to do it if the service account stuff is too much. All right. That was the authorization server. That's Fiat. Obviously, it contains all of the resolved permissions, and whenever a user is trying to gain access to a system or to do something, if it's either to read the state of your application or to actually make mutating calls, each of the other different services need to be able to talk to Fiat, and that's where this code comes in. So the Fiat API client library is baked in to all of these other services, specifically Gate, Orca, Cloud Driver, and Front 50, because these are the kind of the key points of where accounts or applications are accessed. So Fiat will actually, and we're going to step through kind of what this looks like. Since these are all microservices, they're all just accepting HTTP calls. But before they actually get to the controller, they actually get to the application code, they run into a Fiat intercept. And if you're looking at the code, this is what a Fiat intercept looks like. So you got your application controller, whatever controller it happens to be. You'll see littered throughout pre-authorize and post-filter calls, where this is talking to the Fiat permission evaluator. This is a bean that is part of the Spring Security Framework that we've hooked into in order to provide the least intrusive way for the application developer to secure their code. So if there are developers out there, people who are interested in extending Spinnaker and writing your own modules and whatnot, this is a good thing to know about, is the pre-authorize and the post-filter. There are all kinds of examples in those 4 modules: Cloud Driver, Orca, Gate. They're kind of littered about the code if you want to go see how to use these. Specifically, the has permission, application, and read. So it's a pretty simple interface to say, I only want people who have this permission to be able to access this call. All right, and so this is just the interface for that permission evaluator. We have a custom implementation of this that everything's open source. You can go look through it. So what is that implementation actually doing? So in this case, the implementation is making an HTTP call to the authorization server Fiat, and Fiat is giving back your entire resolved permission. And so in that case, the permission evaluator is using that data to make a yay or nay decision on whether or not you have access to this resource. So with all of that knowledge, I would highly recommend you secure your Spinnaker installation so that you don't end up with a cloud infrastructure that looks like this. And with that, we're going to use this fancy thing for questions. Who wants it first? I've seen three talks here, and they haven't used these. Cheers.
You want me to
Get to ask a question.
ask a question?
Or throw it to somebody else.
Who's got a real question?
Get it a little closer.
Ready? Okay. So you said with the X Spinnaker user header, does that mean if I present the header root and I'm not authenticated, it'll just assume I'm authenticated as root?
No, it doesn't actually go to the application, to the underlying system. It's just a custom header that says you are who you are, and then that hooks into the Fiat system. So if there's no user root in Fiat, it's going to return 403 forbidden.
Okay, but assuming there is a root user.
Right, and this goes back to the recommendation to put Spinnaker on its own subnet so that end users can't do that. Where is Guard? So Guard was saying that he's a guy from Shipstead that gave a talk this morning. He was saying that this has actually been a very good help for them because their team is the only team that has access to Spinnaker, and if they need to do some administrative maintenance on it, for example, they can write scripts to say, I want to impersonate this user, but because their team is the only one who has access to the Spinnaker installation, they're able to do that. It relies on external security of the Spinnaker deployment itself to actually protect it.
All right. Thank you.
That makes sense? Behind you too.
All right. So this is kind of more around like auth-C. Do you have what are the kind of the future plans for other verbs than read write? Like, say, I wanted developers to be able to deploy, but not necessarily change a pipeline.
Sure. So we started out this. I started out this knowing that I could spend 6 months designing the most elaborate ACL system, and it would be amazing, and everybody would just fall over themselves to say how awesome my system is. But I didn't want to do that because I knew that there was never going to be able to design an ACL system up front that was going to meet everybody's needs. So I took the approach of the Pareto principle, implementing the minimum amount that we were hearing from customers, which was at the time, I want to be able to secure applications, and then I was going to wait, and I'm waiting for feedback from the community to say, what is the next big piece of the security system or the authorization system that we need to implement? Things that I've heard of are like per pipeline ACLs, or some is like down to per stage ACLs, and like those are the kind of things that add a whole lot of extra overhead that may or may not be generally applicable to the broader community, and actually add a whole lot more headache. So so what I'm saying is, like, I don't have any future plans at this point to go beyond application and account until we hear like a march from the community saying, like, we need this, we want this, we can't adopt Spinnaker without it.
This is cool.
Yeah, I know, I like it.
What are the restrictions on like account ACL? Like when the account allows write, what does that actually mean?
Everything.
I mean,
Like, you've got the ability to read and see that server groups, load balancers, security groups, all of these things exist with the read permission, and then the ability to mutate them, to clone, to resize, to destroy, disable, like actual mutating operations. That's everything covered with the write scope.
if I could go on a little further. So let's say I've got application A that a user is authorized for, and it calls a pipeline, runs a pipeline trigger against application B, which the user is not authorized for. Does that pipeline succeed?
So it depends on how your pipeline is set up. There are two kinds of ways for a pipeline to trigger another pipeline. There's an explicit way, which is the run pipeline stage, and then there's the implicit way, which is to say that the trigger on pipeline B is triggered on the success or failure of pipeline A, right? It's a trigger in and of itself. So if you're explicit about it, if you're explicit within your pipeline, you have a stage that says run the child pipeline. Your authentication mechanism is going to go with it. Your identity is going to go with it. And if you don't have access to application B, the first mutating call it might even be the first read call, is going to get a 403, and your pipeline is going to fail. Depending on how you have, and so that's the explicit case. In the implicit case, I think you can still do this. You can set up the run as user to trigger as a separate user, to run as a separate user when that pipeline gets triggered. I have to confirm that. It's been a while since I've looked at that.
Hi. Would you recommend using OAuth 2 or SAML?
OAuth 2.
For reasons more than just the number of groups, or other reasons as well?
Part of it being that like you don't necessarily need your administrators to your system admins to get everything set up. I found that it's much easier to debug from the client side, like actually running through the Chrome dev tools and seeing what's going by. That being said, you could still do that with the SAML assertions. You just need extra tools to kind of decode the XML that's going across the wire. At least in here, if you know the three-legged OAuth flow, you can see each of the requests being made and which code is going where, like the control flow.
With the discussion around the subnet and how easy is it if we wanted to configure mutual TLS between these entities to protect the OAuth? I guess something like JWT or something like that would be more difficult probably to put in. That requires more development. But at least the TLS piece, can that be easily done?
So I would refer you to some of the Netflix guys who have that set up, the mutual TLS thing. They open sourced a tool to kind of help with server management. I think it was called Lemur. Do you have any Netflix people here? Jairus, is that?
Lemur, it is. Yeah.
It is?
Yeah.
Yeah.
Saw it on-
Okay, then I'm wrong.
So yeah, I think there's Netflix has developed an open source tools for managing client-side certificates. So I would suggest looking into that, short of having your own Metatron service that Cameron talked about. Other than that, Catriel, you guys did MTLS too?
Yeah, but we did the hard way.
You did it the hard way. So it's a handful of configuration settings within each of the different services to say, I require client-based authentication.
I've set it up. I guess I'm trying to figure out whether there's standard support for it in Halyard or something in case you want to set it up.
Yeah, given that, so the question would be like, is it ever going to be in Halyard? I doubt it because there's so many variables in there in terms of like self-signed certificates or like using your enterprise's certificate signing in order to get
for mutual
proper client
TLS.
certs.
Sorry. Is this for mutual TLS?
Yeah.
No, that actually should be in Halyard. I'm thinking that odds are you supply your certs to Halyard that you want to. It's going to be a lot of certs you have to generate and sign yourself or have someone sign for you. But then it would configure mutual TLS for you. The approach right now is that it is deployed into an environment that's isolated, like Travis said, with a subnet or with some firewall rules. But TLS should end up in Halyard. It's not in there yet, but hopefully next quarter.
There you go.
Hey, so I heard some question about securing the pipeline and authorizing who makes changes to the pipeline. So I'm from Capital One. We have our internal compliance policies that once the certified pipeline is in production, nobody should change it. And if it's changed, it goes through a review process. So one of the options that we have implemented is we have utilized the GitHub authentication and approval and review process. So any pipeline changes that happen and users apply the changes, it goes to GitHub process of review. And once the pipeline is certified, then the pipeline is enabled back into Spinnaker itself. So just wanted to share that how Capital One has addressed some of those compliance things within our organization.
Thank you.
I'll try my best.
All right. Hey, that was a great talk. Thank you. Is there any support around using like groups with the Next 509, like LDAC groups or something?
Yes. So
Why? I'm missing something here.
Edwin just implemented that. And I think is there a PR? Was that merged?
No, we're still at work. We have the whole week off for like target specific events, so it will be PR'd in a couple days probably.
So to answer your question, the role extractor for X509, of which there is an interface already in Gate but no implementation, that implementation is becoming open source soon.
Yep. And we're also going, so I just found out about Lemur. Lemur does something like what we're going to open source, but we're open sourcing something that's called Harbor Master, which could create certificates for the X509 integration that we're writing. So that way you can use those two tools to do X509.
I have a question about Roscoe and the Roscoe logs, which in this world it seems are not touched at all, but you'd also still want to keep Roscoe protected either via MTLS or a private subnet. Is there any plans to make the Roscoe logs securely accessible?
I didn't have any plans for it. That is a good question, though. The thing about Roscoe is that when you invoke a Roscoe bake, Roscoe doesn't know anything about the application that's being baked. It just has its Packer template. It just has its a set of configurations and whatnot. It doesn't know. There's no way for me to tell at the API level that this applies to this particular deployment account, or this is a request from this particular application. So that's the reason why like Roscoe doesn't have. That's why Roscoe doesn't have any like those pre-authorized and post-filter accounts in there. You won't. I don't think you'll find any in there. But that is a good question about reading the logs. I'll have to look into that, and we'll talk with Matt Duffler about that. He's the guy that wrote Roscoe.
Cool. Thanks.
Yeah, thanks. By the way, great work with Fiat. We use it and we are super happy with it. Do you have plans or requests to add some sort of admin functionality, like admin read everything or admin read write everything? Or?
There is an is-admin call that always returns true. That is guaranteed to be random and chosen by a fair dice roll. I put that in as a placeholder, expecting that somebody would ask this question eventually. So the hook is there. There are a handful of spots in front 50 where that admin call is checked. And that is because there's a handful of endpoints in front of 50 that were considered like administrative batch updates. I think Netflix built this in whenever they were having to do pipeline migrations from one format to another. They would actually download all of the pipelines, do a handful of grep commands to change a particular format or to change the Orca execution engine or something like that. And then they would re-upload those into front 50, which would then turn around and store them into S3, right? So that was the point of that. And that did not seem like a end user function, so I put them behind like an is-admin call. But like I said, everybody's considered is-admin. So if you want to help me, write out an implementation of as we have here the permissions, perhaps there's a way that we can say here is the list of roles that Spinnaker administrators have, and when you are a Spinnaker administrator, you have access to both read and write every pipeline, or read or write every application or account. And would anybody how many people here are administering your Spinnaker deployment? Okay, so do your admins require super user access? I imagine they would. Yeah. So yeah, let's talk about what that implementation might look like.
Hi, I may have missed the point earlier, but I'm wondering what is the case when a user changes roles or even move across different applications? How do you manage that?
So that when the roles change for a particular user, that generally will get picked up. So that's most of the time happening in some other external system. User A gets added to Google Group B, right? Whatever that ends up being. It can take by default up to 10 minutes for that change to be picked up within Fiat, because Fiat is periodically syncing to the Google Groups API that says, all of the users that I know about, go get me all of their roles, and in kind of this big batch update, and then we're going to resolve all of the permissions. We're going to store all of the permissions in Redis, and then whenever that user comes back, those new permissions will be reflected. Does that answer your question?
Yes, thank you.
So you mentioned for the API earlier, X509 was the option that Netflix had kind of been going with. Especially with tools like Rower and other CLIs and things, is there ever going to be, or is there a plan to allow you to authenticate with a username and password to the API at some point in the future? I know right now that doesn't seem to be an option.
So like for Spinnaker to manage its own its own set of users.
Well, I wasn't sure if there would be a way that we could, leverage whatever the identity provider is, but give it access to at the API level, not just the UI. Like right now, when I log in, it redirects me to my SAML provider and then gives me access to Gate and DEC. But it would be nice if there was some way to do that programmatically, so that if I have a CLI for Spinnaker, it prompts me for my username, it prompts me for my password. It still talks to the identity provider. But right now, it has to be done via X509, as far as I know, is the only option.
So one of those filters that we looked at, that external auth token filter, that was actually built partially for this. That might be a restriction on the SAML implementation, depending on how like your script, like how it's going to assert that it is who it says it is. If that script was able to acquire a SAML assertion, and it can post that SAML assertion to Gate, that flow will work just like any other user has, because that's how maybe. I think that should work with SAML, but I think you still have to work with the identity provider, where the identity provider is the one that is actually posting the assertion to Gate's endpoint, and saying that this user with this session is established to be authenticated, and that then when your script user with that session cookie makes calls to Gate, then everything will be good. The OAuth flow kind of makes this a little bit easier. There is, so like I said, with a GitHub personal access token, that's how this flow works, and it works really nicely with the GitHub auth flow. For the Google OAuth, there is a tool that I haven't played with, but I've read about. It's called OAuth tool, OAuth 2L, that I believe the intent is to help make acquiring a bearer token easier for programmatic script access. Like I said, I haven't actually played around with that, but I do know that tool exists, and that is its purpose. Not much more for SAML though. Like I think SAML was designed for a much older web stack than this. So.
I could have saved you, but
Sorry.
That'll be the last question because we got.
Good thing it's soft.
At the provider level for authorization, do writers also have read permission, or is it
No.
explicitly read write?
It is explicitly read and write. Okay. If you look at DEC, though, we've implemented this as you have read access and you have read and write access, but that is just kind of a stylistic thing that we expect most users are going to, if they want write access, they're going to want both read and write access. We didn't want to catch somebody up that's like, hey, we couldn't see this, well, because you didn't explicitly say read access.
That was the solution to my problem that I was talking to you about earlier.
If people want to talk about X509 and how we're going to be using it for scripting, and specifically the PR that we're working on, let me know and I can demo it to you. If we could go to the breakout room.
Cool. Thank you guys. Thank you guys for coming.